Good morning, dear students. A warm welcome to all of you for our today's digital session for the subject Science and Technology Section A. In our previous session, we have completed with the numerical examples and activities, additional questions for lenses and chapter number 5 heat. Also, we had started with the introduction for a new chapter, chapter number 8, Metallurgy. We have started with the chemical properties of metals. In today's session, we are going to continue with the study of chemical properties of both metals and non-metals. Then we will start with the introduction, the information about ionic compounds, and then the different concepts related to the name of this chapter, metallurgy. So in the first 2 to 3 minutes, let us see the reactions of metals with oxygen and water, which we have studied last time, and then we will start with the new topic. First, we have seen the reactions of metals. Reaction of metals with oxygen. The basic funda here is metals combine with oxygen on heating in air and metal oxides are formed. Offline in the lab, we have seen burning of magnesium in air, in oxygen, in the presence of oxygen. The compound metal oxide, magnesium oxide was formed. Today we have done the experiment in the lab. Here sodium and potassium, these two metals are found to be highly reactive, very reactive. Sodium metal, it combines with oxygen in the air even at room temperature and it forms sodium oxide. You can see 4Na, that is sodium in the solid state, combines with oxygen forming sodium oxide. On exposure to air, sodium readily catches fire. So you can see it reacts even at room temperature, and when exposed to air it readily catches fire, and hence to prevent such types of accidents in the laboratory, you will always find sodium is kept immersed in kerosene because it does not react with kerosene. The reaction of sodium oxide with water, you can see here oxides of some metals, they are soluble in water and they react with water to form alkali. So sodium oxide reacts with water forming sodium hydroxide, which is nothing but a base and alkali. Magnesium oxide is the other metallic oxide which is formed on burning magnesium ribbon in air. This experiment we have done in the lab. Magnesium oxide reacts with water to form an alkali called magnesium hydroxide. So first is the reaction of formation of magnesium oxide, and second, this magnesium oxide when treated with water forms magnesium hydroxide. This we have studied last time. We have just revised the reactions. Next we had seen the reaction of metals with water. Here I had told you calcium, it reacts with water very slowly and less vigorously, and in this process when calcium reacts with water, the gas liberated is hydrogen. So this liberated hydrogen gas, it collects on the surface of calcium in the form of bubbles, and then the metal, the calcium, floats on water. So this is the chemical reaction. Calcium when treated with water forms an alkali, or you can say a base, calcium hydroxide, with the liberation of hydrogen gas. Very beginning, last time I had told you this chapter is full of chemical equations and reactions. Their balancing, their physical states of reactants, products, everything should be memorized by you very thoroughly. So prepare a chart, and every day at least 5 reactions if you prepare thoroughly, then there will be no load on you during the board exams. Next is about the other metals like aluminium, iron, zinc. A very important characteristic here is they do not react with cold or hot water. Instead, they are found to react with steam to form their oxides. And you can see the reaction of aluminium and zinc with water. These were the topics which we had seen last time. Our new topic for today is reaction of metals with acids. In the textbook it is given with oxygen, so the heading is wrong. Just make the change there in old textbooks, page number 95. C is reaction of metals with acids. Now, when the different samples of metals like aluminium, magnesium, iron, zinc, they are treated with acids, that is either dilute sulfuric acid or hydrochloric acid, then the particular sulfate or chloride salts of that metals are formed. And when a metal reacts with any acid, then the liberated gas here is hydrogen. Magnesium reacts with HCl, that is hydrochloric acid, forming chloride. You can see sulfate or chloride. Sulfate is when they react with sulfuric acid. So magnesium chloride and hydrogen gas. Aluminium, when treated with HCl, it forms aluminium chloride with the liberation of hydrogen gas. Now I will not read the balancing part. You have to learn to balance the equation on your own. Wherever possible, memorize, and wherever not possible, try the balancing on your own so you will not go wrong. Fe, that is iron, reacts with HCl forming iron chloride with the liberation of hydrogen gas. Zinc reacts with HCl forming zinc chloride and hydrogen gas. So basic thing you remember that whenever a metal reacts with acid, a particular salt of that metal and hydrogen gas is liberated. So you will not go wrong. Our next is reaction of metals with nitric acid. Especially they have given with nitric acid. So nitrate salts. In the previous case you have seen when sulfuric acid then sulfate. Hydrogen chloride or HCl then chloride salts. So when it is nitric acid, the salts form are nitrate salts of metals are formed on reaction of metals with nitric acid. Now here you have to study about the nitric acid in two stages. One is when it is concentrated and one is when the nitric acid used is dilute. So copper reacts with concentrated nitric acid forming copper nitrate, nitrogen dioxide and water. When it is treated with dilute nitric acid, it again forms copper nitrate. The gas here is not nitrogen dioxide but nitrogen oxide and liberation of water. See the balancing carefully. In the exam, the question when you are told to write the reaction of metal with nitric acid, then you have to write for both. One is in the case of concentrated and one with dilute. The balancing is different in both the cases. Next topic, that is reaction of metals with salts of other metals. That topic they have removed out from the syllabus. So our next small topic is to study about the reactivity series of metals. So many metals you have seen the names: calcium, zinc, magnesium, aluminium. So the reactivity of all metals is not the same. However, different reagents like oxygen, water and acids, they are not useful to determine the relative reactivities of all the metals. Why? Because all the metals do not react with them. So how you can determine the reactivity series? You have studied about the displacement reaction in chapter number 3. So the displacement reaction of metals with solutions of salts of other metals, it serves this purpose. If example you take a metal A displaces another metal B from the solution of its salt, then what you can say that the metal A is more reactive than metal B. You have studied about the reaction of iron reacting with copper sulfate. Experiment you have done in the lab. How iron nails, they corrode or they turn reddish in color. So you can see over here, what do you mean by this reactivity series? The definition here is the arrangement of metals in the increasing or decreasing order of reactivity is called the reactivity series of metals. If you are showing it in the decreasing order, then the higher reactive metal will come on the top and then it will go on decreasing. If you are showing it in the increasing order, then the metal with the lower reactivity will come on the top and then it will be shown in the increasing manner. So that arrangement is known as reactivity series. Now, metals are divided into different groups according to their reactivity. The first is highly reactive metals, the other is moderately reactive metals, and the third one is less reactive metals. You have a chart in your textbook and the names I have not displayed here. You have in the textbook the names. On the top you will have potassium, sodium, lithium, calcium, followed by magnesium, aluminium, zinc, iron, tin, lead, then copper, mercury, silver and gold. And then how they react with water, with acids, with oxygen. The ones on the top are highly reactive and towards the bottom are low reactive. So this chart can be asked in the exam and then you have to identify or categorize the metal and put them in their proper group. Our next topic is reaction of metals with non-metals. Very simple. Metals with non-metals. Now you have studied about the noble gases in the earlier standards. The noble gases like helium, neon, argon, which have a complete duplet or octet and hence they do not participate in any of the chemical reactions. So we have seen from the reactions of metals that cations are formed by the oxidation of metals. And if we look into the electronic configuration of some metals and non-metals, you have studied last year how to write the electronic configuration. Then what is seen that the driving force behind a chemical reaction is what? It is to attain the electronic configuration of the nearest noble gas with a complete octet. You take the example of sodium. It comes in contact with chlorine. It will donate its electron which is there in the outermost shell. What is the main attempt by sodium is to become stable by losing that one electron and becoming stable with an octet of 2,8 which is nothing but neon. So what is the driving force behind a reaction? To attain the electronic configuration of the nearest noble gas. Now how do the metals do this? They do by losing the electrons, while non-metals, example chlorine, they do it by accepting or gaining electrons. So here you can see an example. An ionic compound sodium chloride is formed when sodium metal gives away one electron while the non-metal chlorine takes up that electron. From the last year, that is the 9th standard, you have studied the topic formation of sodium chloride. How sodium gives away that one electron, how chlorine takes up that one electron, both become stable and form a new compound, ionic compound, sodium chloride. Why ionic? Because the positively and negatively charged ions are formed in the reaction. So chemical reaction is here. 2Na plus Cl2 gives 2NaCl. Apart from this, magnesium, potassium, they also form the ionic compounds MgCl2, KCl respectively. So it is not only that sodium does it, other metals also form ionic compounds. With this we complete with the first topic from metallurgy, that is the chemical properties of metals. Now we move towards the chemical properties of non-metals. Now what are non-metals? Non-metals are nothing but a collection of elements having less similarity in physical and chemical properties. When we have started with metals, I had told you that they lose electrons easily and become positively charged ions. So metals we call as electropositive elements. But when you speak about non-metals, they are electronegative elements. Why? Because they form negatively charged ions by accepting the electrons. Now some of the examples here you can see. The first is reaction of non-metals with oxygen. You have studied in the previous part reaction of metals with oxygen. Now here it is non-metals with oxygen. Now non-metals, they will combine with oxygen to form acidic oxides, Not only that, in some cases neutral oxides are also formed. So we take the non-metal here as carbon. Carbon, when treated with oxygen, it forms CO2, that is carbon dioxide. Complete combustion, acidic oxide is formed. Carbon, when treated with oxygen, it can also form carbon monoxide. See here it is di because to oxygen, here it is single. So monoxide, partial combustion. Here the oxide which is formed is neutral oxide. Another non-metal, if you take sulfur, when treated with oxygen, it forms sulfur dioxide, which is acidic oxide. So you can see that not only acidic oxides, but in some cases neutral oxides are also formed when non-metals combine with oxygen. The next we will see is reaction of non-metals with water. See, whatever you have studied with the reaction of metals with oxygen, with water, same you are studying for non-metals. Reaction of non-metals with water. Now, generally if you see, non-metals, they do not react with water except the halogens. What are halogens? The ones which have 7 electrons in their outermost orbit, like chlorine, bromine, iodine. Here you can see one example. Chlorine, on dissolving in water, it gives this reaction Cl2 plus H2O, that is water, forming HOCl plus HCl, both in the aqueous state. Next is reaction of dilute acids with non-metals. You had studied reaction of metals with acids. Now here it is reaction of dilute acids with non-metals. Now here also non-metals do not react with dilute acids. Halogens are exception to this. Here also you see non-metals do not react with water except the halogens. Here also non-metals do not react with dilute acids. Halogens are an exception to this, and you can see an example. Chlorine reacts with hydrobromic acid, that is HBr, forming HCl, that is hydrochloric acid, and bromine, Br2, both in the aqueous state. And last is reaction of non-metals with hydrogen. Now non-metals, they react with hydrogen under certain condition. Which condition? Proper temperature, presence of pressure, use of catalyst, etc. So if these conditions are supplied, then only you will see that non-metals are found to react with hydrogen. You can see a small reaction here. Nitrogen, when treated with hydrogen gas, it forms 2NH3. NH3 means ammonia gas. Sulfur also reacts with hydrogen, forming H2S, that is hydrogen sulfide. So these are the different examples, equations. So our entire part, the first you can say topic of this chapter, that is chemical properties of metals and non-metals, is over. What you have studied in this topic is nothing but the different reactions. You have to prepare a chart. How to prepare this topic? Prepare a chart. Make 2 columns. In the first part you write metals. Second part you write non-metals. Then write reaction of metals with oxygen, reaction of non-metals with oxygen, reaction of metals with water, reaction of non-metals with water, then with acids. This way you prepare the chart, write all the reactions below it, and then every day go through the reactions. Then your first part will be ready for the exam. Don't mug up. Prepare the reactions. Try to balance on your own. Remember about their physical states very carefully, because here you will tend to lose the marks when it comes to decide the quality of the paper, especially the students who get full marks. If a child has written this equation very correctly, the child has scored full marks but has not written the physical states. Whereas on the other hand, there is a paper who has also written the reaction correctly, who has also scored 40 marks but has expressed the physical states, then the one who has not written will get a deduction of 1 mark and will come to 39 out of 40. So how to increase the quality of your paper is by skipping the laziness. Everywhere try to provide all the information which is given in the textbook. Our next topic is Ionic Compounds. What do you mean by this term ionic compounds? how an ionic compound is formed, I need not tell you, because from the 9th standard you have studied the formation of sodium chloride, common salt, which is nothing but an ionic compound. Ionic compounds are nothing but the compounds which are formed from two units, that is the cation and anion. They are called as ionic compounds, a simple definition. The same example we will take for you to understand. Sodium, when it donates one electron, it forms a positive ion, whereas chlorine, which takes up that electron, forms a negatively charged ion. So when the compound is formed from the combination of both sodium and chlorine, where ions are formed, such a compound is called an ionic compound. Now, the cation and anion, one is positively charged, one is negatively charged. Both are oppositely charged, and hence there is an electrostatic force of attraction between them, and this force of attraction between the cation and anion is called as ionic bond. I hope you have understood what are ionic compounds, what is an ionic bond. In the previous standards also you have studied about this. Now, the number of cations and anion in a compound and the magnitude of the electric charge on them is such that the positive and negative charges, they balance each other, and so we can say that an ionic compound is electrically neutral. The number of cations and anion in the compound and the magnitude of electric charge on them is such that the positive and negative charges balance each other. If you are given plus 2 chocolates and then minus 2, plus 2 minus 2, no chocolates left with you. Okay, so you are neutral. There are no chocolates in your hand. So similarly here, an ionic compound, you can say, is neutral in nature. Now we will see its other properties. The first is ionic compounds are crystalline in nature. What do you mean by crystalline? Last year in the 9th standard, chapter number 13, carbon an important element, there you have studied about the crystalline allotropes. So crystalline means it is present in the form of crystals having definite arrangement of atoms. Now, if you see the surfaces of all the particles of a crystalline substance, they have a definite shape, they are smooth and shiny. If you take the example of common salt, the common salt which actually you get in the granular form in the market, not the powdered form, they are shiny. They have a definite shape, definite arrangement of atoms. Here, after definite shape, the regular arrangement of ions in the solid ionic compounds, that is mainly responsible for the crystalline nature. Now, the arrangement of ions, if you see, the positively, the negatively charged ions is different in different ionic compounds, and if you see, the shapes of their crystals are also different. So, ionic compounds are available in the crystals of different shapes. Here, different give reasons can be asked. Now, the main factor that determines the general arrangement of ions in a crystal is the attractive force between the oppositely charged ions and the repulsive force between similarly charged ions. Now, two of the important factors which are responsible for a certain crystal structure. The very first factor is the size of the positively and negatively charged ion. If you take the example of sodium chloride, sodium is the positively charged, whereas chloride is the negatively charged ion. Second factor is the magnitude of the electric charge on the ions. Now, if you see, the electrostatic attraction in the neighboring ions with opposite charges is very, very strong, and hence we have seen that the melting points of ionic compounds are very high, and also the nature of this ionic compounds is they are very hard in nature and they are brittle. Now, we will see the general properties of ionic compounds which are stated in the textbook. The first property is ionic compounds exist in the solid state and are hard. Just now I have told you that the attractive force between the positively and the negatively charged ions, that is the cations and anions which form that ionic compound, is strong. And this attractive force being very strong makes the ionic compounds very hard and when they exist in the solid state. Second is ionic compounds are brittle and can be broken into pieces when pressure is applied on them. Here I have stated melting and boiling points of ionic compounds are high. Why they are high? It can be a give reason. You know the intermolecular force of attraction is high in ionic compounds and a large amount of energy here is required to overcome it, making the melting and boiling points of ionic compounds very high. The intermolecular force of attraction being high, you cannot easily break the bonds between them. And so, the melting and boiling points of these compounds are very high. If you see about their solubility, ionic compounds are water soluble. Water soluble. This is because the water molecules orient in a particular manner around the ions separated by the process of dissociation, and as a result of this you will see a new force of attraction between the ion and the surrounding water molecules. Next, if you see about the solvents like petrol and kerosene, you will find that the ionic compounds are insoluble in the solvents. About the conduction of electricity, ionic compounds cannot conduct electricity in the solid state, but they can conduct it in fused or molten state. Cannot conduct electricity in solid state. Why not in the solid state? Because the ions cannot leave their places. Why they cannot leave their places? Because the intermolecular force of attraction is high. See how the concepts are linked with each other. And as the ions cannot leave their places, they cannot conduct electricity in the solid state. But what is the, you can say, reason that they conduct the electricity in fused or molten state? In this state, the ions become mobile. They start moving. The aqueous solutions of ionic compounds, they also conduct electricity as they contain the dissociated ions. In acid, bases and salts last year, we have studied about the process of dissociation. And on passing current through the solution, the ions move to the oppositely charged electrodes, the positively and the negatively charged electrodes, cathode, anode. And due to the electrical conductivity in fused and dissolved state, the ionic compounds, they are also called as electrolytes. So here we end with the properties and the explanation of ionic compounds. Now the different types of questions possible here are, a direct question here can be asked about give any 2 to 3 properties of ionic compounds for 2 or 3 marks. Here there can be a give reason. Melting or boiling point of ionic compounds are high. Why they are high? Or the third case, the paragraph which is given in your textbook on page number 98. That paragraph they can print and give it to you, and based on the paragraph they will ask you the questions. Just we will go to the previous slide. You can see over here. This way the paragraph will be printed ahead of you, and then they will ask the questions. Comprehensive questions are there in science, you know it. What do you mean by an ionic compound? Give one example. Then you can give the example how NaCl is formed. Or next year you know about its properties. They can ask different questions on the properties and the 2 factors which are responsible for the crystalline structure. So this is about the ionic compounds. Our next topic is the main theme of the chapter. The name of the chapter itself lies in this topic, metallurgy. Now, 2 topics are left. The one is metallurgy, where in the first part you are going to study the small terms which are related to metallurgy, then the basic principles of metallurgy, how you obtain pure metal from the ores, the different stages. After that, we are going to study about the extraction of one of the metals, that is aluminium, and towards the end we will study about the corrosion of metals. Metals, they corrode. So how the corrosion takes place, in which ways, and which are the different techniques by which you can prevent the corrosion, that will be our last topic. So we will require 2 more sessions to complete this chapter. Very important, very lengthy, but if you revise it every day, then it will not be difficult for you. So in our next session, we will start with a new topic from metallurgy, the different concepts related to it and its basic principles. So till then, we wind up with our today's session. Keep on reading the textbook, keep on completing your notebook, and keep on revising each and every topic every day to avoid inconvenience and difficulty towards the end, that is your board exams. Thank you, dear children.